Hi there, everybody. Welcome back to another Chem Complete lecture in the Statistics series. And in today's lecture, we are going to take a look at the different variable typings and the different types of data that we can come across when we are engaging in statistics and studies. So get ready for that because that is coming up on the channel right now. Okay, thank you so much for learning with Chem Complete today for all of your statistics needs. And again, remember to head on over to chemcomplete.com. There are lots of free resources over there to help you in your STEM-related studies. So, getting started with variables and types of data. We're going to break this down and we're going to look at variable typings first, and then we will look at the different types of data that we can come across. And after we finish each of these kind of somewhat brief sections, we will have a test yourself section to make sure that you are following along and everything makes sense. So there are several different variable typings. They really fall into two larger categories, quantitative and qualitative. And then underneath quantitative, we kind of have two subcategories, being discrete and continuous variables. So let's take a look at each of those. A quantitative variable is going to be a variable that can be counted or can be measured. So basically, we can associate numbers or values with quantitative variables. Now, in the opposite sense, a qualitative variable is going to be a variable with distinct categories according to some sort of attribute, but we cannot assign a value or a number to it, at least not one that is measured or meaningful. So an example of a qualitative variable could be if I go to a parking lot and I see different colored cars and I start counting how many blue cars, how many red cars, right? The number itself could technically be quantitative, but colors would be qualitative, right? Red, blue, green, those are not numbers. They are qualitative variables. Now, something that could be a quantitative variable would be, for instance, the heights of different patients that attend or go to a specific practice for a primary care physician. Now, under quantitative variables are two subsets. We have discrete variables and continuous variables. Discrete variables are going to be values that can be counted individually, which when I say counted individually, I mean whole numbers. So in other words, I could count them off and say 1, 2, 3, 4. Okay, an example of that would be, let's say, how many dogs does your family own? Well, it could be 0, 1, 2, 3, 4, etc. But you're not going to have 2.5 dogs or 2.66 dogs. So when you count them individually, you get whole discrete numbers in your counting. Now, on the other hand, continuous variables are going to be values that contain an infinite number of values between two specific values. So a continuous variable could be something such as, let's say, a GPA. So when I'm calculating the GPA for a student, it's not just 1, 2, 3, 4. I could have a 3.5. It could be a 3.52. And technically, even though most schools will cut it off at a certain decimal point, those could go out and out and out as we continue forward. So continuous variables are values that are going to technically be able to go out an infinite number of decimal places when we are taking that measurement. All right, so here's an example to test yourself to see if you know the difference between these. Are these examples discrete or continuous in nature? So you can read these here. I'm going to read through them once. I would suggest that you pause the video, and then once you feel confident in your answers, you can unpause the video and follow along. So number one, we have the amount of time a high school senior spends on the TikTok app each day. Number two, the number of touchdowns scored by a quarterback. Number three, the amount of money earned per week by a student working a summer job. And then number four, the weights of students in a 6th grade class. So a middle school class, the weights meaning the how much mass or what is the weight of those individual students in that class. So pause the video, try these out, and then unpause it when you're ready. Okay, so hopefully you had a chance to try these out. We're going to go through each of these now and see if you can follow along as we go through. So number one, when we're looking at the amount of time a high school senior spends on TikTok a day, this would be continuous. Now, the reason that this would be continuous is that time could technically be broken down further and further as we move along. So while you could look at it as minutes, you could also technically get into seconds, you could get into milliseconds. Time can be measured, and you do not have to discretely count time, right? If I say how much time has gone by, even though you might be counting 1, 2, 3 in terms of seconds, you could measure that, right? We can get more and more broken down with those decimal points as we continue forward in terms of time. All right, number two, the number of touchdowns scored by a quarterback. This one would fall under discrete. And the reason that this would be discrete is that when we look at a football game or something of that nature, if you are scoring touchdowns, they just simply count as a touchdown. This quarterback has made 1 touchdown, 3 touchdowns, 5 touchdowns, 0 touchdowns, right? But you don't have 2.5 or 3.7 touchdowns or something of that nature. The amount of money earned per week by a student working a summer job. Now, because most of us have a tendency to look at money as dollars and cents, some people might get tempted at first to put continuous here because they see it and they go, oh, well, it's $1.34 if they earned $1.34 or so on. And so while that may be tempting at first, the correct answer here is that this is discrete, because even though you may end up having cents, we can break those down into pennies, and those pennies are not going to be divisible as far as a paycheck is concerned. So when you get paid to the nearest penny, and then that is it, right? Most places, or at least that I know of, are not issuing fractions of a cent. You might get that from some sort of an interest account, but even then they still cut it off at a specific tenth of a cent, hundredth of a cent, whatever it might be, right? We do not go out into infinity when we're talking about money like that. The weights of students in a 6th grade class. So this one is going to be continuous, and some people may be tempted to put discrete here because they would say 30 pounds, 70 pounds, 85 pounds, whatever it might be. But those are all coming from measurements, and technically a scale can go past the ones unit. You could find a 1/10 of a pound, a 100th of a pound, and if you got a scale that was sensitive enough, you could go into thousandths or millionths of a pound. There is no stopping point, technically speaking. So this would be a continuous measurement as I am measuring it using some sort of measuring device. It just kind of is going to hit a wall depending on how specific that device is as far as measurement is concerned. All right, so moving on to data types here. There are 4 major data types that we can come across in statistics, and I have them ranked here, and you can see each of them. So the first is nominal data, and this is going to be data that we find in a mutually exclusive category. So what that means is that it's not going to have any sort of order or ranking to it. Essentially, most of these are just going to be yes/no questions, or they are going to be picking from a specific list. So to give you a couple examples, let's say that we are giving a survey and we ask somebody about their religious preference or their religion that they identify with. That would be an example of nominal data, right? There's no order to it. If I were to say Christian, Jewish, Muslim, none of that would make any sort of sense as far as ranking them. Okay, marital status would be another example. You are either married or you are not, or maybe you're widowed, but you're in a specific group that makes it mutually exclusive to the other categories. Gender would be another example of that, and so on. Okay, so then we have ordinal data. Ordinal data is going to be a situation where data is in categories that can be ranked. However, the precise differences do not exist between those ranks. So some examples here could be, for instance, winner ranks. Let's say that we're talking about a science fair and you get first place, second place, third place, right? Those ranks, we can put an order to them, first, second, and third, but we can't find a measurable or a specific number difference other than calling them first, second, third, okay? Or winning a race, right? You get first, second, or third place in the race. Well, the difference between first and second is not always measurable or continuous. It is just whoever came in first, and whoever came in second, and so on. Letter grades is another example of this, okay? Even though you might have 90s, 80s, 70s, which do have numbers, if you just say A, B, C, D, we can rank those letter grades, but technically we do not have an official number attached to them. Now, by convention, a lot of times we'll say 100 to 90 is A, and then 89 to 80 is B, but that's not a guarantee. You could have people that curve their class, you could have institutions that set up a different grading scale. So we do know that A is the highest grade, B is after that, C is after that, and so on, but that would be an example there, okay? And then something like general size. So let's say I'm ordering a pizza, and I can choose from a small, a medium, or a large pizza. Even though many pizza places may add specific, this is a 12-inch pie or a 14-inch pie, that is technically ordinal data when you're just saying large, medium, and so on, right? So the next one is interval data. Interval data is going to rank data with precise differences between units. However, there is no absolute zero that will be present when we look at interval data. So some examples here could be things such as the IQ scale, which does not have an absolute zero, but is relative based on the results. Another common one that I certainly know or use often as a chemist is the Fahrenheit and the Celsius scale. So Fahrenheit and Celsius, it is possible to go below zero. There is such a thing as -10 degrees Fahrenheit, and so on. Okay, so because they can be measured, we can actually take a look at specific measurable units for it. We do not have a 0 point for those units. And then finally, you can see ratio data is going to be almost the same, but now we do have those 0 units. So the ratio data will rank data with precise differences between the units, but there will also be an absolute 0 that is present in this situation. So examples of that include things like the Kelvin scale for temperature, which does have an absolute 0. And there are many other examples. So let's say the amount of weight that you could lift in the gym. You can zero out on that. It is a number, and it is a measurable number. However, once you hit 0, you cannot dip below that. There's no such thing as lifting negative amounts of weight, right? The number of calls that you receive on your phone daily, and so on. Those would all be examples of ratio data. So similar to what we did above, let's go ahead and test you and see if you understand each of these. So the question here is, what type of data typing is present? And your choices for the answers will be nominal, ordinal, interval, or ratio. So let's take a look at each of the questions. Again, I encourage you to try them yourself before you end up attempting to walk through and use the video. So number 1 is going to be the ages of the top 20 best-selling authors. Number 2 is the colors of hoodies available from a store. Number 3 is going to be t-shirt sizes available on a store shelf. Number 4, rate how you feel today, and you see several options. 1, I hate my life. 2, meh. 3, stoic. Stoic means indifferent or don't really care. Okay. 4, pretty happy. And 5, this moment is the zenith of my happiness, meaning I can't get happier than this moment right now. And then number 5, the temperature each day in September, and let's use Fahrenheit to measure that particular temperature reading for all of the days in September. So go ahead and try each of these and see what you come up with, and then we will walk through them in just a moment. Okay, hopefully everybody had a chance to attempt these. So ages of the top 20 best-selling authors. Technically, as ridiculous as this may sound, this is ratio. Okay, it's ratio because there is a number that I can associate with the ages themselves, right? I can't say that it's just nominal or ordinal because there is some sort of order to the ages that makes sense. Now, it may seem kind of silly that it is ratio, but if you think about it, that does make sense because 0, even though we wouldn't expect to have an author at 0 years old that's writing as a baby, there is a bottom or a floor to the age. You can't get below 0, and so it is ratio. Okay, the colors of hoodies available from a store. Hopefully everybody was able to realize that this is nominal. If I am simply looking at the colors associated with the hoodies, colors do not have any type of meaningful rank that I can put them in. T-shirt sizes available on a store shelf. This would be ordinal. So we are assuming that when you go to the store shelf, you're picking up a t-shirt and it says extra small, small, medium, large, extra large, 2XL, 3XL, etc. Those are not specific measurable sizes as you are reading them off of the t-shirt. You are just looking at a given set of shirt sizes that have some sort of order to them, but I cannot necessarily assign the values, the actual numeric values. All right, rate how you feel today. And you've got options 1, 2, 3, 4, and 5, which I read through earlier. This is also ordinal, and this one can confuse some people. The reason this is ordinal is that even though there are numbers, right, I can't get a specific measurement, let's say between meh and stoic, right? If I look at those two, I can't say, well, here is the actual numerical difference between meh and stoic. It is 5 happiness units, right? It is 7 happiness units. No such thing exists. So we can say it's ordinal because we can say, well, person at 1 or 2 is not happy, while person at 4 or 5 is very happy. That's all that we can really do with it. We can put it in a specific order. Okay, and then finally, the temperature each day in September using Fahrenheit. This one would most definitely be interval because I can get specific numbers, right? I could say it's going to be, 70 Fahrenheit. It's going to be 22 Fahrenheit. That would be a very cold day in September, but I suppose that's possible. Okay, but the Fahrenheit scale does not have a 0, so this would not be ratio because it could technically be -7 degrees Fahrenheit that day, and so on. All right, so that wraps up our discussion on the variable typings and the types of data that you can come across. So thank you so much for learning with Chem Complete for your statistics needs today. Again, head on over to chemcomplete.com. There's lots of resources available, and it's a great way to support the channel. Like if you found the video helpful, the thumbs up will help keep promoting us in the algorithm. And if you subscribe, you will be up to date with all of the latest information during your studies. So I hope that your day continues to go well, and I will see everybody in the next lecture.